Hey there, I've got a AP question for you, and I'm going to give you a solution on this as best I can. So, we have a problem that deals with blocking. Researchers who are trying a new shampoo formula plan to compare the condition of hair for people who use the new formula with the condition of hair for people who use the current formula. 12 volunteers, now you can't use a highlighter on the AP test, darn it, but you can underline with a pencil. 12 volunteers are available to participate in the study. Information on the volunteers numbered 1 through 12 is shown in the table below. Okay, so we've got this table. We've got males and females, and we've got varying ages here. So the first question asks us, the researchers want to conduct an experiment involving two formulas, a new and current, of shampoo. They believe the condition of hair changes with age, but not with gender. Because researchers want the size of the blocks in the experiment to equal to the number of treatments, they will use blocks of size 2. So we're using 2 people per block. Identify the volunteers by number that would be included in each of the 6 blocks and give criteria used to form the blocks. Okay, so in this case, since they don't think that gender is an issue, I would block these by age. So blocks are created by with subjects of similar ages. So in the first block, I'm going to find the 2 youngest, which happen to be volunteers 1 and 2. So block 1 would be volunteers 1 and 2. Block 2. So I'm going to just put a little dot for those that I've used so that I don't mess this up too much. Block 2, I'm looking for my next 2 youngest. I've got a 24 and a 23, so that would be volunteers 10 and 11. Okay, so I've got those out of the way. Sorry, I'm thinking through this as I go. I'm not really, I've looked the problem over, but I haven't really, I'm not looking at a key. So I'm kind of trying to make it as realistic as you might. Okay, so my next 2 youngest, I don't have anybody in the 30s. It appears as though my next 2 youngest are both 44 years old. Volunteers 8 and 9. So block 3 is going to be 8 and 9. Block 4. I've got a 47 and a 46, so that's going to be 3 and 12. And then I have a, let's see, what do I have? I've got a 58 and a 60. Those are my next ones. So block 5 is going to be my 58, 7 and 4. I'll write that as 4 and 7. And block 6 is going to be the last 2, which are going to be the 62 and the 61-year-old, 5 and 6. Now, you might do something like this. And take note that we're talking about volunteers here. So that could be a problem for us later on, so be aware of that. Okay, so the next part of this is part B. Part B says, other researchers believe that hair condition differs with both age and gender. The researchers will also use blocks of size 2 in their experiment, identify the volunteers by number that would be included in each of the 6 blocks, and give the criteria you use to form the blocks. So in this one, they think age and gender is a problem. So we would want to put these guys together with similar ages, but the same gender. So I'm going to make that comment. Blocks are created by combining volunteers of the same gender and as similar an age as possible. Okay, so we'll do the best we can with this one. So I'm going to start with block 1 being my 21-year-old male here. So I've got a 21-year-old male, and I'm trying to find the next youngest male. I've got 47, 61, 58, 44, and 23. So I'm going to have 1 and 11 will go together. So block 1, I'm going to put male, 1 and 11. Let's do block 2. At this point, you can kind of decide, do you want to go with all the males first and then all the females? I don't think that matters. I think to keep things simple for me, I'm going to just go with all the males first. So I'm going to go with my next oldest male, or next youngest male, which I believe is 44. And the next closest male in age to that would be, let's see, I want to make sure I'm not missing something. 44, I've got 58, 61, and 47, so it's going to be the 44 and the 47, so that's 9 and 3. Let's see, I'm going to write that as 3 and 9. It doesn't really matter. Okay. And I'm down to my last 2 males. So that's going to be the 61-year-old and the 58-year-old. So that's 6 and 7. What do I have? 6 and 7. All right, now I'll do the females. And let's see, my 2 youngest females, I've got the 20-year-old and a 24-year-old. So that is number 2 and number 10. Block 5, female. Let's see, what do I have? Then I've got 2 females, 60 and 62, so it's got to be the 44 and the 46, so that's going to be 8 and 12. And then block 5, oops, block 6, not 5. It's also female. That is going to be my 4 and 5. I'm going to change those to ands. I did that on the other one. Okay. So I believe that gets us totally squared away for A and B. That should be at least 2 of the 4 points. C is going to be the big question. Researchers in Part B decide to select 3 of 6 blocks to receive the new formula and give the other 3 blocks the current formula. Is this an appropriate way to assign treatments? If so, describe a method for selecting the 3 blocks and receive the new formula. If not, describe an appropriate method for assigning the treatments. Okay. Here's where you have to think about this. We have volunteers, and we are placing them in blocks, which is totally fine, but we have no randomization, and we need some randomization. So if they just simply pick the blocks, it's entirely possible that one group of 3 blocks that gets the new product could be all male of differing ages, and then the old product all female of differing ages. So what we really want to do is we want to do like a matched pairs design for each of these blocks, where one person in each block gets the old treatment and one person gets the new treatment. So I'm going to say the appropriate, or the method mentioned by the researchers is inappropriate because there is no randomization. There is no randomization. How about within the block? And you could say, and it probably would be good if you had the time, you could say it's entirely possible that all males get the new treatment and all the females get the old treatment, or something like that. I think that would be a great statement. I'm not going to make that statement here, but I think that would be excellent. A matched pairs I'm just going to make a note, twins. I wouldn't say that on the AP exam. This is for you. Design for each block. Would be appropriate. Where a subject from each block, a subject in each block is randomly selected to receive the new treatment, or to receive the new shampoo. I guess it's a new formula. And the other receives the old formula. let's see. Now, this would get you a long way on this question, but there's something missing. And the thing that's missing is, how do we select? And there's a lot of ways you can choose to say this. You could use the random digits table. You could say that you'd use some randomization with oh, I don't know, the calculator. It can do some random selections. But I think I would, for each block, I would put the names, put the two names of the subjects, into a hat or a container of some sort. They like into a hat. And remember what I've said, and shake the hat. Then without looking, draw one name for the new treatment or whatever. I guess I'd say the new formula. Now, not 100% sure. You guys can look at the data that I've given you in some of the other files and some of the other examples. How'd I do? Do you think I got a 4 on that? I think I got at least a 3, if not a 4. I believe I'm in the 4 range on that one. Anyway, a great problem. Certainly, I hope you gave this a try yourself. If you stumbled a little bit somewhere, that's okay, because the more practice we can get with this sort of thing, the better we are. And I'll try to get at least one of these out every week, if not a couple of them. So, anyway, I hope everybody's doing well, and I'll hope to see you soon.